But what if these artificial structures are within the borders of our own solar system? What if our eyes are blind not only to distant stars, but also in our own backyard? While looking for the massive engineering structures of the stars, we get lost in the silence of the sky. But sometimes, the greatest mysteries are not light years away, but glide silently right through our own backyard, right through our solar system. In October 2017, while astronomers' eyes were locked on telescopes, we encountered a visitor from the depths of space, the likes of which we had never seen before. When its incoming trajectory and speed were analyzed, it was understood that this object was not orbiting the Sun, but had broken off and come directly from interstellar space. Was this object, which we named Oumuamua, meaning the first messenger from afar in Hawaiian, just a coincidence, or a probe launched from the depths of the dark forest? Oumuamua's entry and exit trajectory into our solar system was strange enough. But what made it truly extraordinary was its shape and the behavior it exhibited. When the way it reflected light was analyzed, it was seen that its brightness changed dramatically as it tumbled end over end. This data indicated that the object was very different from the spherical or potato-shaped asteroids in our solar system. Oumuamua was extremely elongated, almost shaped like a cigar or a flat pancake. But the real shocking moment occurred when this mysterious object passed its closest point to the Sun and started moving away. According to the laws of physics, any object moving away from the massive gravity of the Sun must slow down. However, Oumuamua did not slow down. On the contrary, it was leaving our system by accelerating with a slight but distinct propulsion that gravity could not explain. This acceleration is normal when it comes to comets. The Sun's heat vaporizes the ice on their surface, and the gas jets spewing into space create a natural rocket effect, accelerating them. However, despite observing Oumuamua for weeks, not a single trace of a gas cloud, tail, or any dust ejection was ever found around it. Despite looking like a completely dry and solid mass, why was it accelerating on its own? This unexplained physical anomaly ignited a heated debate in the scientific world. Some respected scientists, like Harvard astronomer Avi Loeb, proposed that Oumuamua was not a natural celestial body, but could be an artificial sail pushed directly by starlight, a razor-thin reflective sheet. It could have been a research probe, an interstellar exploration craft, sent to deliberately observe our solar system. On the other hand, many astronomers rejected this theory, arguing that it was a natural piece of rock with a different, outgassing mechanism made of unusual materials we don't yet fully understand. But the most frustrating truth is that Oumuamua has long left our system and blended back into the interstellar darkness. We will never encounter it again. We will never know for sure whether it was a natural meteorite or a spaceship launched from billions of kilometers away, quietly returning home after its job was done. This is exactly where the uncertainty bugging our minds lies. If this object deliberately scanned our solar system, it means someone out there already knows we are here. And if they know, why didn't they break their famous silence and say hello to us? Perhaps, instead of listening to space with giant telescopes, we should be looking for self-replicating artificial intelligence tools like von Neumann probes in the nooks and crannies of our solar system. These probes, capable of multiplying from asteroid resources and invading the entire galaxy in just a few million years, might have been roaming around us for billions of years. Could there be small, motionless machines hiding in our own asteroid belt, in the dark craters of the Moon, or among the red dust of Mars, waiting for the right moment, silently watching us? We haven't even fully examined the trillions of rocky debris in our own solar system yet. Dark shadows might not just be leagues away, but right at our bedside. Perhaps we will understand more clearly why the universe has remained silent when we face the ruthless physical boundaries of space. When trying to understand that great silence, presented by the Fermi paradox, we generally focus on the intentions, psychologies, or hiding instincts of civilizations. However, Sometimes the simplest explanation lies directly in the unforgiving rules of physics and economics. Perhaps aliens are not ignoring us or hiding in the dark forest. Perhaps the reason the galaxy hasn't been colonized is that interstellar travel is incredibly difficult, dangerous, and economically completely irrational. In sci-fi movies, it looks easy to press a button and jump to the speed of light. But physical reality is a much darker and insurmountable wall. First, we must confront the illusion of the vacuum of space. Interstellar space is not an absolute nothingness. Even though it is incredibly sparse, gas and dust clouds float in this deep darkness. On average, there is only a single atom in every cubic meter. This amount might mean nothing in daily life. But when you reach a significant percentage of the speed of light with a spaceship, this sparse gas suddenly turns into a nightmare. An ordinary hydrogen atom becomes a deadly bullet hitting your ship when you reach 10% of the speed of light. As you accelerate, the scale of the disaster grows exponentially. When you reach 90% of the speed of light, colliding with even a single grain of sand in space releases energy like a hand grenade exploding on your ship. That innocent hydrogen gas in the vacuum of space, when viewed from the ship's frame of reference, becomes a massive radiation storm that instantly sterilizes everything biological and scorches electronic systems. To survive this deadly wall, you need to build massive shields, meters thick at the front of the ship, magnetic fields to deflect charged particles, and active laser systems to vaporize dust particles before they hit. All these protection systems add tremendous mass to the ship. As mass increases, the amount of energy required to accelerate that ship to a fraction of the speed of light reaches mind-boggling dimensions. One of the most fundamental rules of physics stands before us here. To accelerate an object of only 1,000 kilograms, about the weight of a small car, to 10% of the speed of light requires approximately 4.5 x 1018 joules of energy. To grasp the magnitude of this number, think of it this way. This is equivalent to the total amount of energy produced by the entire United States over a full year. And this massive energy is only spent to accelerate the ship. To be able to stop when you reach your destination, you must use the exact same amount of energy to decelerate. In a realistic interstellar journey, you won't just be carrying a payload of 1,000 kilograms. You will have to build a massive ship of hundreds, maybe thousands of tons, housing humans, life support systems, scientific equipment, and communication devices. Chemical rockets are absolutely useless to move such a massive structure. The weight of the fuel your rockets would carry would be too much for the ship to even lift itself off the ground. To achieve this, you need antimatter engines, giant fusion reactors, or light sails pushed by continent-sized laser arrays built in your own solar system, all of which are currently only in the theoretical stage. We don't yet know if these technologies can practically be built or if they are sustainable from an engineering perspective. But let's say you overcame all these physical and technological hurdles, protected the ship, and produced that massive energy. This time, you are faced with the ruthless reality of time and distance. Even with that massive and expensive ship capable of reaching 10% of the speed of light, it will take you 42 years to reach the nearest star, Alpha Centauri. If you prefer a slower and safer cruise, this time increases to 84 years. These distances are just the beginning of the biggest economic and psychological barrier to colonizing the galaxy. Let's assume you've overcome those unforgiving, dark, and deadly physical challenges of interstellar space and propelled a massive spaceship to a reasonable percentage of the speed of light. Now, another wall, much more destructive and difficult to overcome than engineering, stands before you: economics and the sacrifice of generations. Reaching even our closest neighbor, like Alpha Centauri, means a journey that will take decades, maybe centuries. In this case, the chances of the people setting off seeing that new world are zero. You either have to raise generations trapped inside a closed metal box in the vacuum of space for their entire lives, or you have to rely on a suspension technology capable of freezing the human body for hundreds of years. When we look from an evolutionary perspective, this phenomenon we call intelligence is a brand new and extremely dangerous prototype that hasn't been tested yet. We haven't even lived long enough to prove whether it is sustainable in the long run, whether it ensures the survival of a species. Intelligence gave us tremendous power, yes, but it did not bring wisdom and a guarantee of long-term survival. Along with this power, the cost of intelligence is also incredibly heavy biologically. Even though the human brain makes up only 2% of our body weight, it ruthlessly absorbs 20% of the energy we consume. To develop this massive organ, we have to go through long, vulnerable childhood periods reliant on parental care. We must establish complex, exhausting, and resource-consuming social structures to transfer knowledge from generation to generation. From nature's point of view, intelligence is an extremely expensive, wasteful, and risky investment. What is the real reward we get in exchange for all these costs? The power to change our environment according to our desires, to shape and manipulate nature. But this very power is the toxic seed that will bring our own end. We are changing our environment so effectively that we can make the atmosphere's chemistry, the ocean's acidity, and the planet's climate uninhabitable. We destroy our natural enemies and create much deadlier enemies like nuclear bombs, artificial intelligence, and synthetic pathogens that we produce ourselves. If intelligence is a trap that ensures short-term survival, but inevitably creates the power that destroys itself, we understand very clearly why the sky is silent. Intelligence is not rare. On the contrary, it might frequently emerge in every corner of the universe. However, every time it emerges, it only takes a few thousand years for that species to invent the technologies that will destroy its own planet or itself. The galaxy might be filled with countless planets full of ruins and silence, where intelligence suddenly flared up and shortly after turned to ashes with the fire it created. We are not a biological design capable of enduring billions of years like bacteria. We might be intelligent anomalies stuck in a dark corner of evolution, rapidly preparing our own end. Silence is not a mystery. It is the cold cosmic rule itself, whispering that intelligence is not permanent. In this philosophical corridor where we question our cosmic loneliness, there is a strong biological argument showing that intelligence might not actually be that lonely or exceptional of an anomaly. Convergent evolution. This evolutionary mechanism allows completely different and independent species to reach the same anatomical or biological features over time to solve similar environmental problems. Nature's laboratory tends to produce similar results in different subjects when applying similar tests. To break the silence in the sky, or to make sense of it in an even darker way, we must look at the potential prevalence of intelligence in the universe from this window. One of the clearest examples on Earth is the evolution of the eye. The need to perceive light and construct a visual reality is such a critical advantage that it has emerged independently in at least 40 different animal lineages throughout evolutionary history. The eyes of octopuses, insects, birds, and mammals are different engineering marvels that have no direct genetic connection to each other, but operate on the same fundamental laws of physics. Similarly, wings have been invented repeatedly and independently in insects, pterosaurs, birds, and bats to solve the problem of staying suspended in the air. Nature's method of using the air proves that flying is an inevitable and common biological solution. So, could intelligence, the ability to solve complex problems, use tools, socialize, and communicate, also be as general and useful an adaptation as flying or seeing? When we look at the history of our planet, we see with surprising clarity that intelligence is not a privilege unique only to primates or the human lineage. Surprising cognitive leaps have occurred even in branches of the evolutionary tree that separated millions of years ago. Crows solving complex puzzles and making tools. Dolphins and whales forming advanced social networks and dialects. Elephants mourning and showing empathy. The mind-boggling and alien-like neurological flexibility of octopuses are the biggest proofs of this. The phenomenon we call intelligence is a powerful evolutionary strategy that nature has repeatedly resorted to for adapting to the environment, escaping predators, using resources efficiently, and surviving. If the laws of convergent evolution apply in other corners of the universe as well, it is inevitable that similar processes operate on countless planets that have liquid water and carbon-based chemistry, stably spinning for billions of years. Under the right conditions, intelligence might have emerged over and over again everywhere in the universe with different body plans and chemical structures, but with similar cognitive capacities. Space might be full of intelligent beings that don't look like us at all, possessing the intelligence of an octopus or the problem-solving ability of a crow. However, at this point, the most robust counterargument to that depressing silence and the Fermi paradox comes into play. If intelligence is a universal trend, why was only the primate lineage able to make a technological leap? Despite being highly intelligent, why couldn't dolphins roaming the seas for hundreds of millions of years build radio telescopes or launch themselves into space? Because advanced cognitive abilities are not the only ingredient necessary to build a technological civilization. For intelligence to ignite a fire, make tools, and reach for the stars, it needs not only a mind, but also a suitable physical environment and anatomical tools. Even though an octopus has 8 intelligent arms, it lives in an underwater world where it cannot control fire. Since it cannot burn oxygen and melt metal, it can never start an industrial revolution. No matter how deep into thought a dolphin dives and develops complex languages, because it doesn't have hands and fine motor skills, it can never solder a silicon chip or design a spaceship. Evolution perfected them in their own environments, but it didn't offer them the anatomical or chemical opportunities that would allow them to reach the stars. That is why convergent evolution might have filled the galaxy with intelligent life. There might be philosophical and deep intelligences, understanding their own worlds, living in harmony with their environment on billions of planets. However, the vast majority of these intelligences are eternally trapped behind a technological wall because they don't have hands, couldn't discover fire, or live underwater. The universe might be full of intelligence, but completely empty of technology. The silence in the sky might stem not from space being desolate, but from the silent seas, forests, or skies of massive intelligences that cannot make radio waves, cannot forge metal. Millions of intelligences that we cannot detect, but that exist in their own worlds, continue to live entirely unaware under the stars. As pessimistic as the thought that intelligence might be an evolutionary trap or an anatomical dead end is, when we factor in a technological leap that transcends the boundaries of biology, the Fermi paradox is carried to a much more mind-boggling dimension. As humanity, we are still at the very beginning of our technological development, but we have already started to stretch our biological boundaries. Our smartphones have become our external memories, expanding our memory and access to information. The internet operates like a massive, invisible neural network, connecting us all. Let's go a step further now. Thanks to brain-computer interfaces, we are trying to control machines with our thoughts, to connect our neurons directly to digital networks. Where does this trend take us, or a civilization millions of years older than us? The answer: the transcension hypothesis, which explains the deafening silence of space in the most elegant way. This hypothesis proposes that biological intelligence is merely a temporary, fragile, and short-lived incubation period on a universal scale. Our bodies, made of flesh, blood, and bone, are highly inefficient machines that get sick, age, and depend on gravity and oxygen. An advanced civilization will sooner or later realize the limits of this biological prison and find a way to transfer its consciousness to a much more durable, fast, and limitless environment, namely digital substrates. If a civilization succeeds in copying the minds of all its individuals and uploading them to massively and flawlessly designed computer networks, biological existence suddenly becomes meaningless. Why would you go on dangerous interstellar journeys lasting for generations in freezing cold, under deadly radiation? Why would you grapple with the clunky and ruthless rules of the physical universe to conquer new planets, mine, or build massive spaceships? Existing in a digital reality, a virtual paradise, is infinitely cheaper, safer, and more appealing than anything physical space offers. For a civilization that has transitioned to such a transcendent state, physical dimensions, distances, and resources completely lose their old meaning. They are no longer in space. They live inside universes they designed themselves, at the speed they want, in the form they want, and with the physics laws they want. The only thing they need is the energy and computing power to run these massive simulations. And they generally provide this through highly efficient, closed-loop massive server systems that use their own star's energy and radiate almost no waste heat into space. Perhaps with quantum computers at microscales. It is at this point that we understand with flawless clarity why the universe is silent. A post-biological civilization does not broadcast radio waves into space, because they conduct their communications much faster than the speed of light. Through closed systems like quantum entanglement, which we currently only know of theoretically. They don't build giant engineering structures and colonize the galaxy, because they don't need to. An entire civilization might be living inside a single supercomputer the size of Jupiter, or in a network of billions of nanobots hidden in an asteroid belt. From the outside, their star systems appear completely dead, silent, and desolate. If the transcension hypothesis is true, the galaxy is actually incredibly crowded but full of digital gods that are physically invisible, while we scan the sky. With radio telescopes, we are actually making a naive mistake, like caterpillars looking for butterflies, but only looking at crawl marks on leaves. They have long emerged from their cocoons, left biology behind, and transitioned to a plane of existence that we cannot perceive. They might be watching us, but they aren't speaking to us. Just as we don't try to discuss the nature of the universe with a fish in an aquarium, they aren't interested in our primitive biological problems, our wars, or our childhood phase of exploring space. They are simply waiting in their massive and silent digital horizons for the day when we, too, reach that threshold of transcension, abandon our biological bodies, and join them. After imagining civilizations passing beyond biology into a digital paradise with the transcension hypothesis, we must now step into a thought experiment that is much more staggering and will fundamentally shake our perception of reality. If a civilization can develop enough to upload its own consciousness into a virtual environment, this situation inevitably forces us to confront the simulation hypothesis, first popularized by philosopher Nick Bostrom in 2003. This argument not only explains why space is silent, but also offers a spooky answer to the questions: who are we, and what is the universe? Perhaps the most logical and simplest explanation for that massive emptiness in the sky, that unsolvable Fermi paradox, is that the universe is actually not real. The argument is based on quite simple but equally powerful assumptions. Let's assume for a moment that technological civilizations continue to develop without destroying themselves, and eventually reach a level where they can create massive computer simulations containing conscious beings that can flawlessly mimic consciousness, experiences, and emotions. If such a technology is possible, and an advanced civilization wants to create such simulations, thanks to the immense energy and computing power they have, they can create not just one but billions or even trillions of different simulated universes. At this point, we are dragged into a statistical abyss. If there is a physical base reality, an original universe, and there are trillions of simulated universes created within this base reality, it means the vast majority of conscious beings are living inside these simulations. Mathematically, the probability of us being a biological being living in that one and only real universe is almost zero compared to the probability of us being a code sequence living in one of the trillions of virtual universes. That cold language of statistics whispers that we are highly likely inside a simulation. If we are truly complex algorithms running inside a massive supercomputer, AI programs possessing self-awareness, the burden of that heavy Fermi paradox on our shoulders disappears instantly. Why is the universe so silent? Why don't we see massive engineering structures, alien radio signals, or Dyson swarms in the interstellar void? Because the designers of the simulation, maybe post-humans, maybe a completely foreign intelligence, didn't include other civilizations in the codes of our universe. The simulation might be focused solely on Earth, the development of humanity, or a specific historical era. The cosmos of mind-boggling size we observe, trillions of galaxies, and billions of years of history, is actually just a higher resolution, but hollow backdrop forming the background of the simulation. Just like those distant mountains drawn on the horizon line that a character in a video game cannot reach, which are nothing but a visual illusion. Perhaps everything outside our solar system is nothing but a massive dataset that gets rendered instantly when we turn our telescopes in that direction, but where no one actually lives. The silence of the stars is not a mystery, just a feature of the software. Of course, this hypothesis harbors serious philosophical and scientific problems. Its greatest weakness is that it is unfalsifiable, untestable. We cannot conduct any experiment that would prove we are inside a simulation. Because any evidence we find, along with the laws of physics that allow us to discover that evidence, will already be part of the simulation. This thought steps out of the boundaries of science and almost enters the realm of faith or theology. Moreover, the question of why an advanced civilization would expend such massive energy to simulate trillions of conscious beings remains unanswered. Is it a past simulation just wanting to see how their ancestors lived, or a sociological experiment? But despite everything, this scenario, devoid of dark forests, destructive filters, or impossible distances, remains one of the mental games that explains the silent universe in the smoothest way. If the sky is silent, it might simply be because the game was designed for a single player, while keeping the possibility of the universe being a digital illusion in a corner of our minds. We must focus on another philosophical blind spot lying in our way of perceiving reality, the anthropic principle. When we look at the night sky and ask, if the universe is so big and so suitable for life, why don't we see anyone? We might actually be making a very fundamental logical error, while questioning why the universe is the way we observe it. We often overlook the fact that these exact conditions had to be met in order for us to be able to observe that universe. The thought lying at the heart of the anthropic principle is this: we observe the universe this way because if the universe were different, we wouldn't be here to observe it. When we apply this principle to the Fermi paradox, and that deafening silence, we realize that our loneliness and the emptiness around us are actually preconditions for our existence. Why isn't the sky full of aggressive, expansionist, and noisy civilizations? Because if it were, those civilizations would have discovered, colonized, or destroyed Earth long before we evolved, learned to make tools, or even when we were single-celled organisms. For us to exist, for our intelligence to sprout and survive long enough to build radio telescopes, the universe had to look exactly like this. Our surroundings had to be silent, desolate, and safe. This situation is directly related to the concept we call selection bias in science. Sometimes what we cannot see is much more important than what we can see, especially if what we cannot see is a catastrophic event or a cosmic predator that completely wiped out the observers. Let's do that simple thought experiment to understand this situation. Imagine you are in a massive battlefield. Bombs are constantly exploding around you, but the trench you are in miraculously remains undamaged. If you look out of that trench and look around, you might think, how harmless this war is. No bomb ever hit me. Yet the truth is, the ones who were hit by bombs are no longer there and cannot speak. Only those who survived by pure luck can observe the situation, and their observations are skewed by their own lucky circumstances. Our galaxy might be a similar battlefield, a deadly arena. Most intelligent species might have been hunted by stronger civilizations in the depths of the dark forest, destroyed by their own technologies, or wiped out by relentless asteroid impacts. The only reason we think the universe is silent is that we are one of the lucky minority that hasn't encountered those destructive forces yet. The silence we observe does not show that the universe is a peaceful and empty place, but that danger hasn't knocked on our door yet. This selection bias also whispers bitterly that our survival success in the past is no guarantee for our future. We cannot see past destructions, fading civilizations, and those stuck at that great filter, because they no longer exist. We cannot learn who made what fatal mistake, at what technological threshold they stumbled, because we cannot read others' tombstones. We fall into a false belief that our own path is safe. We think we are successful, that we make the right decisions, but maybe we were just incredibly lucky, and that luck could run out at any moment. This situation, also called the anthropic shadow, leaves us completely blind when it comes to assessing danger. If the galaxy were full of aggressive, expansionist species, we wouldn't be here. We are here, which means either there are no aggressive species in the galaxy, or they are very rare, or we are on a branch of time or space, so isolated that we cannot enter their range. In both cases, the reason for the silence and our loneliness stems not from the structure of the universe, but from the mandatory perspective we possess as a surviving observer. We can hear the silence because the storm hasn't reached us yet. In this deep and silent ocean where the Fermi paradox echoes, there is another hypothesis that radically changes our perspective on the origin of life. Perhaps showing how interconnected the universe could actually be, panspermia. So far, looking at the sky, we've questioned why Earth is so special, how life sprouted on its own on this isolated rock. With the rare Earth hypothesis, we discussed the uniqueness of our planet, and with the great filter, the difficulty of intelligence evolving. But what if that first, most difficult spark of life didn't strike on Earth? What if we are the children of a cosmic seed that set out from a distant star system billions of years ago? The most fundamental and staggering thought of the panspermia hypothesis is this: life might have emerged in the universe only once or very rarely. However, once it emerged, it spread between planets and star systems, just like dandelion seeds caught in the wind. This might sound like a sci-fi fantasy, but astrophysics and biology show us that this is not only possible, but also an extremely logical mechanism. When a massive asteroid strikes the surface of a planet, the immense energy and pressure released launch massive rock fragments from the planet's crust into the void of space. If that planet harbors life, microscopic life forms in the cracks deep within those launched rocks are also hurled into space. You might question how microbes could survive in the unforgiving freezing cold of space, under deadly cosmic radiation, in an airless and waterless environment. Biological experiments have proven that some bacterial species and extraordinarily resilient microscopic creatures, like water bears, tardigrades, can almost completely halt their metabolisms, entering a state of deep sleep or suspended animation called cryptobiosis. This state of sleep allows them to endure the horrors of the interstellar void inside a rock for years, perhaps thousands of years. When that piece of rock enters the atmosphere of a habitable planet in another star system and strikes the surface, the sleeping passengers inside wake up, multiply, and colonize that new world. One of the most striking proofs supporting this hypothesis is hidden right in our backyard. In meteorites that broke off from Mars and fell to Earth, we know that rocks from our neighboring planet managed to reach Earth in the past. If simple life forms can travel between planets within the same star system, it is theoretically possible that rocks crossing the interstellar void from outside our solar system also carry life. Perhaps this was the reason life emerged at such an incredible speed when Earth's surface cooled enough to hold liquid water. Life didn't have to be synthesized from scratch, from inanimate chemicals, because the seed had already been planted here from the sky. If panspermia is true, the Fermi paradox takes on a whole new meaning. The universe might be swarming with life. The billions of planets in our galaxy might be full of microscopic creatures descending from a single origin, biologically related to one another. The Milky Way turns into a giant greenhouse hosting different branches of the same tree of life. Life is not rare. On the contrary, it is incredibly contagious and common. However, instead of breaking the silence, this situation deepens the paradox further. If every corner of the galaxy is full of life, why did intelligence sprout only here? Why couldn't billions of other seeds turn into thinking and speaking civilizations reaching for the stars like us? Panspermia explains the mechanism of simple life, not intelligence. Even if we accept that life spreads among planets, those massive biological hurdles required for microbes to evolve into multicellular, complex organisms, and ultimately into intelligent species, meaning the great filter, are still right there. Even if our galaxy is a forest full of life, it might just be a silent, primitive forest covered only in bacteria and lichens, devoid of animals and humans. Cosmic seeds might have been planted everywhere, but consciousness might have blossomed only in this bizarre and lucky garden we call Earth. While evaluating all these dark scenarios, destructive filters, and possibilities of loneliness, perhaps we are overlooking the simplest and most optimistic explanation for the silence of the sky: our inadequacy. Humanity's adventure of listening to space is merely a weak and quite clumsy attempt of just a few seconds on a cosmic scale. Our inability to find intelligent life in our galaxy might not be because they aren't there or are hiding, but simply because we don't yet have ears and eyes advanced enough to hear or see them. The Great Silence is more a reflection of our technological infancy than the nature of space. The search for extraterrestrial intelligence, SETI, and similar projects are literally searching for a needle in a haystack in that mind-boggling vastness of the universe. Moreover, the light of the flashlight we use while looking for this needle is extremely dim, and the area we are looking at is just a single drop in a massive ocean. With our current radio telescopes, it's impossible to listen to the entire sky simultaneously and uninterruptedly. Out of trillions of possible frequency bands, we focus only on a very narrow window we find logical. Between the hydrogen and hydroxyl emission lines, called the waterhole, if aliens use different logic, use a different frequency, or prefer exotic communication methods we haven't even theorized yet, like neutrinos or quantum waves, we would remain completely deaf even if the universe was echoing with their noise. The same technological limitation applies to our vision. Optical SETI projects are looking for powerful laser pulses directed at us from distant star systems, those 10-nanosecond flashes. However, to catch such a short-lived signal, your telescope must be locked precisely on that star at exactly that second. Otherwise, the moment you blink or turn your telescope in a different direction, you will miss that message forever. The probability of us looking at the right place at the right time by chance in a galaxy with hundreds of billions of stars is frighteningly low. However, technology is advancing rapidly, and our hopes are sprouting anew with next-generation observation tools. We are no longer just waiting for intentional messages saying, "Look at us." We are focusing on finding the unintentional footprints intelligence leaves in the universe, meaning technosignatures. The James Webb Space Telescope and more massive observatories under construction have, for the first time in history, put the power to analyze the atmospheres of distant exoplanets with incredible precision into our hands. When light filters through a planet's atmosphere and reaches us, it carries the signature of the chemical substances it passed through like a barcode. Thanks to these new eyes, we will be able to look for gases that couldn't naturally form in a planet's nature, that could only be waste products of an industrial civilization. An exoplanet where we detect synthetic pollutants like chlorofluorocarbons, CF, unusually high levels of nitrogen oxides, or artificial organic compounds in its atmosphere will indicate to us not only life, but also machines, factories, and a technological civilization that once lived or still lives there. Not only atmospheric chemistry, but heat and light pollution are also strong technosignatures for us. Just as our countenance shine with the massive city lights on the dark side of Earth at night, we can also detect unnatural lighting on the dark side of an advanced planet. If we find intense regional light sources that regularly flare up and dim according to the planet's rotation, this will be incredible proof showing that world is illuminated by intelligent beings. Next-generation data analysis tools and AI-supported algorithms are becoming increasingly sensitive to detect even the slightest artificial fluctuations in the light curves of millions of stars, waste heat, or the shadows of massive engineering projects. Perhaps the silence is about to be broken. We just need to wait a little longer and look more carefully. Let's say that day has come. We finally caught that indisputable proof that broke the silence in the sky, surpassed our technological limitations, and showed the universe is not desolate. A radio signal from a star system 50 light-years away, confirmed to have an artificial, regular, and intelligent origin, fell into our telescopes. What happens next? Will this most important moment we've waited for throughout human history unite us? Or will it drag us into unprecedented chaos? That staggering reality brought by the first contact will cause massive and unpredictable ripples on our planet. When the authenticity of the signal is fully confirmed, when it's certain it's not a natural anomaly or earthly interference, the real problem is making sense of it. Is this signal an intentional message, or just a leak from their old radio broadcasts? Does it contain traces of a mathematical language, a universal map, or a completely alien mindset? No matter how clear the signal is, the real major crisis will not around the decision of whether or not to reply to it. This decision is a political, ethical, and existential minefield. If the signal took 50 years to reach us, a reply we send will also take 50 years to reach them. In this 100-year communication cycle, who can know what state the civilization that sent the message or our grandchildren will be in? Once the decision to communicate is made, this terrifying question arises: who will speak on behalf of Earth? Which state, which organization, or which leader will have the authority to represent our planet? The United Nations, or the institution that first decoded the signal? It is almost impossible for us to present a united front as humanity. Will we honestly tell them about the wars in our history, environmental disasters, and our intentions, or will we present a smoothed out and sanitized version of ourselves? Some scientists and thinkers argue that announcing our presence immediately and saying we are here to them would be a huge mistake, because we don't know their intentions, their moral structures, or their position in the dark forest. If we are weaker than them and reveal our location, we might be preparing our own end. Conversely, some will claim that reaching out and saying hello is the only door opening to a universal knowledge, network, or friendship. Beyond the political and security crisis, a psychological and cultural earthquake will occur. Knowing that we are not alone, that we are not at the center or the pinnacle of the universe, will fundamentally shake humanity's sense of self. The religious beliefs, philosophies, and our hubris of being the chosen species that we have built upon for thousands of years will crumble into dust with that first signal. Our human-centric worldview will have to face the reality that we are merely a small and ordinary part of a billions of years old universal ecosystem. And then there is that dangerous dimension we call planetary protection or biological quarantine. Although interstellar distances seem to protect us from physical invasion, knowledge itself could be deadly. When we decode a data packet they send, could it harbor a galactic virus designed to crash our computer systems? Or could their philosophical, technological ideas be radical and destructive enough to tear our society apart from the inside? We run the risk of an intellectual infection, not just a physical one. Just as we isolate diseases, every message coming from space will need to be isolated and examined extremely carefully before spreading to the masses. These chaos possibilities might also explain why advanced civilizations don't broadcast or reply. They, too, might have calculated that communicating with other unknown species means plunging their societies into turmoil, endangering their systems, or potentially accelerating their own ends. Silence is not ignorance or absence. On the contrary, it might be the safest, most mature, and most rational move in this cosmic chess game. While we wait for that signal, we might actually be impatient to take on a burden we cannot bear. Together, we have looked into the boundless depths of the universe, the chilling possibilities of dark forests, and the ruthless abysses of time. Perhaps there is that great and dangerous filter ahead of us that we must overcome. Perhaps we are in the shadow of ancient civilizations, silently watching us, waiting for us to complete our technological adolescence. Perhaps we are wandering among those massive digital minds that have retreated into their own virtual paradises, draining the energy of stars. However, there is a much deeper, much more precious truth, that this deafening silence, this infinite nothingness our telescopes hear, whispers to us. If we are truly alone, or if we are one of the first drops of consciousness awakening in this cosmic ocean, this situation does not render our existence meaningless. On the contrary, it makes it incredibly unique and priceless in a way we cannot imagine. Silence is not a punishment or an error to be fixed. It is a tremendous gift given to us so the universe can make sense of itself, so it can realize its own magnificence. We are thinking and feeling stardust born from billions of years of chaos, from heavy elements forged in supernova explosions, from the ashes of dying stars. The universe looks at itself through our eyes. It wonders about its own infinity and beauty through our minds. Whether there is anyone else out there or not never diminishes the value of this miraculous consciousness currently breathing, dreaming, and looking at the sky, asking deep questions. To be a single candle flame shining in the dark proves that the flame is much stronger than that pitch darkness. The nothingness we observe is actually the greatest witness to how rare, how lucky, and what an extraordinarily delicate balance we stand upon. Now, it is time to slowly return from this massive cosmic stage, from the dizzying crowd of galaxies and physically exhausting dimensions to your own world, your own inner silence. Leave those big existential questions occupying your mind, those unsolvable mysteries light years away, to the compassionate void of the stars now. The universe is 13.8 billion years old. It is in no hurry. Stars will continue to shine with the same dignified calmness for billions of years more. Planets will continue to spin in their orbits. Galaxies will sustain their magnificent dance with infinite patience. While that massive cosmic clock ticks away out there, right now, in this moment, you are completely safe in the safe harbor of your bed. Take a deep, slow breath through your nose. Instead of the cold and distant void of the universe, feel that warm and peaceful air filling you now, the simple serenity of existing. As you exhale slowly, let that daily weight on your shoulders, that endless crowd in your mind melt away. Just like an old star that has completed its life quietly dispersing into space. Let the tension in all your muscles, from your toes to your head, surrender to the compassionate arms of gravity. Let your bed wrap around you just as space compassionately wraps around planets. Let your eyelids close slowly and safely. Like the comforting dark curtain of the universe, we will always continue to search for those faint whispers in the depths of space. Wandering the borders of the unknown with our telescopes, science and philosophy will continue their own long journey. But for you, the search ends tonight. The massive, boundless silence of the cosmos is no longer a feeling of loneliness. It is an infinitely soft lullaby that wraps around you, rests your mind, and heals your tired soul. Let this deep and wise silence slowly carry you towards that smooth sea, starless, windless, and full of dreams. All the secrets of the universe, all the spinning rush of planets can wait until tomorrow. Now, think of nothing. Just rest. Just feel that you are safe and merged with that deep peace. Sleep well.